example which we consider for doing the analysis is linear search. I think we might have done some exercise related to the linear search. Here I can explain you. Linear search is given an array of some numbers. Maybe we can take array of size n. So that means there are n elements available. Array index we can say 1, 2, etc. up to n. So there is an array of size n here. And given an element x, we have to find whether the x present in the array or not. So x present in the array means x can be in any one other position. It may be in the first position or the second position or in the last position or somewhere in between. So if the x is present, we will say yes, x is there. And which location x is present, that will be given as output. So if the x is not present, then we will say that element is not there. So how we can do that? First, let us see the logic. So we can check the first location. If x is present and 1 is the answer, because 1 is the index for that, right? So if 1 is the answer means first location is there. If first location is not having x, then we will go to the second. If there also x is not there, we will go to the third one. So this way we will continue. So that's why it is called a linear search. Doing the search one after another. Okay, in a contiguous positions. So if the element is present in the last location, after verifying the positive n-1 position, we can check the nth position. Okay, so in general, ith position can be verified only after verifying I-1 positions, first I-1 positions. So this is what linear search. Okay, now if we convert that into algorithm, let us name the algorithm as linear search, and let us name the algorithm as array as A, and size of the array is n. Linear search. And one more thing we have to check, that is x, right? Element x. So in this algorithm, what we can do? According to our logic, we can put a for loop. For I is equal to 1 to n do. So this is algorithmic language, not C language, algorithmic language. So for assignment, I am using this symbol. So for I is equal to 1 to n do, because there are n locations available. There, if you are checking, if A of I is equal to x, then, okay, so we'll going from one position to another position like that. Here at any point of time, if you find that position containing x, then we will return the corresponding index. So return I. Okay, and here after checking all the n locations, algorithm not returned anything means the element is not there in the array. Okay, so in that case, we will return 0. So if the algorithm returns 0, the element is not there. You see, once the algorithm returns, anyway, it will come out of the algorithm. So this statement will not be executed. Suppose this return execute, this return cannot be executed. So when this will be executed is, after going through all the position of the array, if the element is not found, then value 0 will be returned. So that means the element is not in the array. So this is what our algorithm. So what important here is how to do the analysis. First, let us take the best case. Best case. So here, the unit of operation. Okay, sometimes to do the analysis, we consider the unit of operation, major unit of operation that we do. So in this case, the unit of operation is comparison. So every comparison 1 unit of time, right? Every comparison 1 unit of time. So there are several possibilities are there. If the element is there in the array, there are several possibilities. So maybe it is in the first position, or it is in the second position, or in the third position, like that. In general, it is ninth position, or it may be in the 10th position. Okay, so it may be in any one other position. So if the element here, this is position, and here let us see the number of comparisons. Number of comparisons required. If the element is present the first position, And how many comparisons they required? Only one comparison. That is our algorithm starting at I equal to 1, right? So if the element is there, immediately it will return. Okay, only one comparison it will do. So if the element is in 2, how many comparisons required? If the element is in the second position, how many comparisons required to tell?
The 2 comparisons.
2, right? Because only after checking the first position, then only we can go to the second, right? So like that, third position means 3 comparison. In general, I means I number of position and n means n number of comparisons that is required. So this is the number of comparisons that is required. Now, here the instant is, you see, the element may be present in any one of the positions. So each one is considered to be an instant where the element is there, right? So if that's the case, the best case value, that is B of n, is equal to the minimum of if the element is in the first position 1 comparison, second position 2 comparison, etc. If it is in the nth position n comparisons. So these are the possibilities where the element is there, right? So there are n possibilities there. For each possibilities, we are given the time. And when the best case we get only when the element is in the first position, right? So minimum value is equal to 1, right? Minimum value is equal to 1. So that means if the element is in the first position, so that gives the least number of comparisons, and that is the best case. So in this algorithm, best case complexity equal to, so asymptotically if we say this is R of 1. So and it can be even stated as theta 1. So this is also theta 1 because this exact complexity. Actually R of 1 nothing wrong because theta 1 is an intersection of R of 1 and omega 1. Theta is intersection of order and omega. Okay, but as a computer scientist, if it is exact complexity better, you have to say theta notation. Okay, so the best case complexity is theta 1. And similarly, worst case, W of n, that is the maximum of, once again, these values, right? 1, 2, etc. n. So what is the maximum value? So n. So that means worst value we get if the element is present in the last position of the array. The element is present in the last position of the array, or element is not present. Or element not present. Even if it is not present, unless we compare the n positions, we cannot say, right? Therefore, the worst case complexity is n. Once again, this is exactly n comparisons required, right? And hence you can say that the complexity is theta n. Complexity is theta n. Okay. Now, the next one is the average case. Here we have to be very careful. Okay. So this average case analysis is not so easy in all problems. Okay. That's why many problems average case analysis won't be there. So people talk about only worst case, but many problems even we can give the average case. But average case analysis is not so simple. But the problem what we have taken. So therein the average case analysis is not much difficult. So the formula for average case is sigma I belongs to Dn P of I T of I. So this is the formula we have seen. So in that the P of I is the average probability. So here for this problem we have to define the probability. But we do not know what the probable value that we do not know. So we can assume that let K be the probability of element present in the array. Present in the array. Let K be the probability of element present in the array. So we do not know exactly, therefore we are taking some K. But the value of K is between 0 and 1 because it's a probability. So if K is the probability of element present in the array, what is the probability of element not in the array? If K is the probability of element present in the array, what is the probability of element not present in the array?
Yes, 1 minus K.
1 minus K. So that implies 1 minus K is the probability of element not in the array. So actually what we want is, we want average probability. What we want is, we want average probability, not the probability of element in the array. Suppose element is present in the array. Okay, suppose element is present in the array. Where it can be present? It can be there in first position or in the second position or somewhere in the middle, or it may be in the last position also. So out of n positions, it may be in any one of the position. So if the element is present in the array, out of n positions, it can be in any one of the position. Therefore, there are n possibilities available, right? If the element is present in the array, there are n possibilities. And hence, the average probability for this case. What is average probability? K by n. So K is the probability of, this is the average probability of element in the array. So K is the probability of element in the array, and there are n such possibilities. So average probability of element there in one position is K by n. Okay. And now, what is the average probability of element not in the array? Can anyone say? What is the average probability of element not in the array? For element present in the array, we know that K by n. So if the element is not in the array,
1 minus K by n.
1 minus K?
1 minus K by n.
No, by n won't come. You see, if the element is not in the array, only one instance, right? So if the element is present in the array, there are n such possibilities. But if element is not in the array, means only one possibility. So it is 1 minus K by 1 only. Okay, 1 minus K by 1 only. Therefore, here the average probability is, 1 minus K alone. This is the average probability of element not in the array. Not in the array. Okay, so we got the average probability. Okay, now we can derive the average case. Now average case A of n is equal to sigma. So here based on the element position we have to write instead of I belongs to Dn, because our instant is element in the array. If it is in the array, where it is. Okay, so it is sigma I equal to 1 to n plus 1. Okay, then P of I, T of I. P of I, T of I. So why up to n plus 1? Actually, array is 1 to n, right? Array is 1 to n. Then why we have taken 1 to n plus 1? Because we have to consider element not in the array also. So for I is equal to 1 to n, it means the element is in the array. For I equal to n plus 1, that is corresponding to element not in the array. Got it? So n possibilities are there for present in the array and one possibility for element not in the array. So totally n plus 1. So this sigma, the summation, I varies from 1 to n plus 1. Okay, now we can split this case into two things. One for the successful case and other one for the unsuccessful case. So that is equal to, successful case is for I is equal to 1 to n. I equal to 1 to n. First n position are for successful. So there in probability of I, the average probability of I. So what is average probability of element in the array? K by n. That already we got, right? Average probability of element in the array is K by n. So we can put K by n. And what is T of I? T of I is the time taken for the instance. So if the instant equal to 1, instant equal to 1, how many comparisons? 1 comparison. If I is equal to, that is instant 2 means 2 comparison. So the instant is depending on the position where the element is there. So depending on the element where it is, that much comparisons we need to do that, right? Therefore, for T of I, the time taken is I comparisons. Okay, then plus n minus 1. So it is up to n only, right? So n plus 1, that is for element not in there. So here, that is only one item, right? So if the element is not in the array, what is average probability? 1 minus k. So we can put 1 minus k. And what is the actual time required for element not in the array? What is t n plus 1? What is t n plus 1?
N comparisons. Sir, N.
That is not audible.
Sir, N comparisons.
N comparisons. Okay, actual time, because you can conclude that after n comparisons, the element is not there, right? So number of comparisons required is only n. So that's the actual time required to tell the element not in the array. Okay, now if you simplify this k by n, we can take it out. Then remaining is sigma I. Sigma I means so that I varies from 1 to n. So that is n into n plus 1 divided by 2. The sum of I. And this is 1 minus k into n. 1 minus k into n. Okay. Now this n goes out. So value is k by 2 n plus 1 plus 1 minus k into n. So this is what the value we get. Okay, now you see our size of the input is n. So based on n only we have to say some k's are there. So average case means you have to see various possibilities here. So for example, element is surely in the array. For example, element is surely in the array, but we do not know where it is. It may be in any one of the position, but it's very sure that element is there in the array. So if you make the assumption, what is the value of k? So k is the probability of element in the array.
1, sir.
And we assume that element is surely in the array, then what is the value of k?
1, sir.
1, k equal to 1, because it's a maximum probability, right? So that is equal to 1. So if you substitute k equal to 1, what happens? So this is equal to, so this value I am writing here. Okay, so this is equal to, here 1 by 2, n plus 1. So n plus 1 by 2. And here if you put k equal to 1, this term goes up, 1 minus 1, 0, right? So this is what the value you get. So asymptotically, this is equal to R of n, right? Because constants under we won't take, right? Constants we won't take. So that is equal to R of n. So that is when the element is surely in the array, the average probability is R of n. Okay, now we assume that suppose the element is not in the array. Okay, element is not in the array. Then what happens? K is equal to
0.
0. So if we substitute k equal to 0, what happens here? So this term won't be there. In this case, it is 1 into n. 1 into n means once again it is R of n, right? The element is there in the array R of n. If the element is not in the array, it is R of n. Okay, now we are not sure whether it is there in the array or not there. It may be there or may not be there. So half chances. So k equal to 1 by 2 we put. K equal to 1 by 2. 1 by 2 means half the probability. The chance is half the probability. Okay. So if that's the case, k equal to 1 by 2 means what you get? You get, okay, that is k by 4, sorry, 1 by 4. So n plus 1 by 4, n plus 1 by 4 plus it is 1 by 2n. So when you substitute, okay, when you substitute k equal to 1 by 2, you get this n plus 1 by 4 plus 1 by 2n. So what's the LCM? So LCM is it visible?
Yes, sir.
Here it's visible. Okay, I can write here. Okay, so that is equal to LCM 4, right? That is n plus 1. Here it is 2n. So that is equal to 3n plus 1 by 4. 3n plus 1 by 4. Once again, you see asymptotically, it is order of n. Why? Because these constants won't be considered, right? So that is equal to order of n. So whatever the case it is, the average average case value of linear search is order of n. Okay, so this is the way the average case will be determined. So best case is theta 1, worst case is theta n, average case is order of n. So this is a complexity for linear search.